Okay, so here we are learning our how to do math for chemistry. Our first problem is 3 over 8 equals x. And this is just checking to see if you can convert a fraction into a decimal. So you say 3 divided by 8 equals, you get 0.375. This is a terminating decimal number, so you would report all of it, and that's all there is to that. Then we have 9 equals 2 over a. And the problem with this is that what we're trying to find, we want to get a by itself, and it's on the bottom. So if we just move the 2, then we would get 1 over a. So we're going to move the a. So the formal way to show this is you'd multiply both sides by a. A over a is 1, so that cancels. So now we have 9 times a equals 2. So we'll divide both sides by 9. 9 over 9 is 1, so that cancels. A equals 2 over 9. Put that in your calculator. 2 over 9 equals. You get A equals 0.222. And this one is repeating, so you could put the line on the 2 if you want to show that. The next one is 8b plus 5 equals 27. Here we want to collect like terms. This is a regular number. This is a regular number. This is a number in b. So we're going to minus both sides from both sides. Right? Minus 5 from both sides. 5 minus 5 is 0. And 27 minus 5 is 22. So we have 8b plus 0 equals 22. 8b plus 0 is 8b equals 22. Divide both sides by 8. 8 over 8 cancels. B equals 22 over 8. 22 divided by 8 equals. B equals 2.75. And that is correct. All right, next we have 5t over 2 equals 9 over 7. So we see that t is on top, so that means we'll get our answer directly, but we have to get the 5 and the 2 out of there. So we can multiply both sides by the reciprocal, 2 over 5, and 2 over 5 here. 2 over 2 is 1, so that cancels. 5 over 5 is 1, so that cancels. T equals, we've got 9 times 2 over 7 times 5. And we put this in our calculator, we're going to say 9 times 2 divided by 7 divided by 5. Because the result of that operation, its relationship to this 5, is that the 5 is underneath. So we take 9 times 2, divide by 7 because that's under, and then divide more by 5. Because at this point, the calculator already has an answer. So we'll say 9 times 2 divided by 7 divided by 5 equals, and we get t equals 0.514, which is correct. Otherwise, if you wanted to maintain that that was multiplied, you'd have to remember to put a parentheses first, then say 7 times 5, close parentheses, and you would get the same answer. So next we have 321 minus 2t equals 8 over 5. This one is a little bit difficult because we've got a negative number here. This is a number not in t, this is a number not in t, but it's a fraction, so I'm just going to multiply 321. I'm going to divide, that's what I want, subtract. Subtract 321 from both sides. So 321 minus 321 is 0 minus 2t. And now this 8/5 I can get in my calculator. 8 over 5 is 1.6 minus 321. Don't have to write that. We just subtract 321. And this gives negative 319.4. So we've got a negative 2t on this side, negative 319 on this side, with a 0. So the 0 doesn't matter. If we multiply both sides by minus 1, then we would say a minus of a minus makes a plus, and a minus of a minus makes a plus here. We're going to divide this side by 2 and divide this side by 2, and that will give 319.4 over 2. So that gives t equals 159.7. There are several different ways to deal with the negative sign. This is just one of them. You could have got, at this point, you could have divided both sides by negative 2. And that would have given the same result. Now we've got 56 times 23 equals 1245 over 5c. So this one lets you know that you can move the c without moving the 5. So we'll multiply both sides by c, and c over c is 1, so that cancels. We've got 1245 over 5. On this side, we've got 56 and 23, so 56 over 56 is 1, 23 over 23 is 1, and we divide by 56 and 23, right? We did that on both sides. Divide by 56 and 23, divide by 56 and 23. So now we have 1245 divided by 5, divided by 56, divided by 23, because all of those are on the bottom. 1245 divided by 5, divided by 56, divided by 23. And that gives me C equals 0.193. And that is correct. Now, if you have a big fancy calculator and you have lots of time, you can go ahead and put the parentheses and put the times and all that. The thing is that with a cheap little calculator and not too much time, or if you're in a timed exam, then you would want to be able to do it with the smallest number of keystrokes possible. Okay, so what was that one? That was that. Okay, so now we have this one, 10 over 3, and the reason this is in here is what if you went along and you worked out a problem and at the end you would say, oh, drat, I got all the way to the end, but here my answer, I have the reciprocal of what I'm supposed to have. So our strategy here is that we're going to raise both sides to the -1, which means that you just flip the fraction. So this will come out 3 over 10, and this comes out p over 1. In your calculator, there's a to the -1 button. On this calculator, it's 1 over x. That's kind of hard to see. It's the second function of this button. And on this calculator is x to the -1. So if we do that, then we would say 3 divided by 10, second function. Oh, it didn't take the 3. 3 divided by 10, second function, 3 divided by 10, second function, whatever x. Why is it doing that? 3 divided by 10 equals 0.3. Shift 1 over x is... Oh, I already flipped it already, that's why. Thank you. Yeah. Okay, never mind. This is 3/10, so that's 0.3 equals p. Right. Otherwise, we'd had to say 10 over 3 and then use the reciprocal button. But since that was obviously able to do in your head, there's no problem. All right. Well, see, that's what happens when you do it the third time. Okay. We've got 3 plus 2 plus 5 plus 7 in parentheses over 4. This is just what could be, if these were measurements, this could be getting an average. 3 plus 2 plus 5 plus 7 equals 17. So 17 over 4, divide by 4, and we get 4.25 equals question mark. That's correct.
Okay, this is the one that I really am having issues with.
So we've got 6 times 4.2 times negative 7.0 equals negative times 110 times 5.4 times x. So we look at the relationship of all of these, and they're all multiplied. So all the numbers are concatenated. They're like like a string of beads. And even though this negative 7 is a result of measurement, and this negative here is a result of theory, we've just got a minus on both sides. And so you just divide both sides by -1, and then this becomes positive, and this becomes positive. Okay? So this minus in the front was minus of this quantity, but you don't have to get the answer first. You can just deal with the minus. And then the x is by itself, so we're going to divide both. This was divided here. We're going to divide both sides by 110 times 5.4. 110 times 5.4. And so the 110s will cancel, the 5.4s will cancel, and you have this whole mess here. 6 times 4.2 times 7 divided by 110, and then that whole answer is divided further by 5.4. And so this would give us x equals 0.296969. And this would be good. We've been instructed to stop after 3.
Okay. And okay, yeah, I got that too.
You got that? All right, so that's correct.
And so you just round that.
You would round, yeah, because the 6 with the 9 following would round to the 7. We're sort of doing this exercise, not really worrying about rounding because we haven't talked about that yet. This next one is 2 times 3 over 3, and this is just to recall that anytime you multiply when the top is equal to the bottom, you get the same thing back again. So this is unity, and this is numerically equivalent, but we could also have some other theoretical equivalents. So 2 times 3 over 3 is 2. And that just checks to make sure you know that. Then we've got 3 times 1 over 4, 0, 0, 0, times 8, 0, 0, 0, 0, 0, 0, over 1. And this one's in here to just remind you can cancel zeros. So we got 3 zeros here, we got 3 zeros there. This gives 3 times 1 times 8,000 divided by 4. So 8,000 over 4 is 2,000 times 3. The answer comes out to be 6,000. This next one is 88.2 times 2.54 over 1 raised to the third power. And so this makes you find out how to raise to the third power on your calculator. On this calculator, I use the this one here, x to the y. And on this calculator, you're going to have to use this caret. So you raise to, and then you would say to the third. So I'm going to put this in first, 2.54 x to the y, 3 for cubed, and I get 16.387. Now I'm going to leave that number on my calculator and take it and directly multiply by 88.2. So that gives 1445. And this is the one the guy asked me about. He said, well, you said to give decimal places. But really, if these had units, then these would have been measurements, and then this would have only been good to 3. When it's pure numbers, you don't really have a rule. So if this had been a measurement, then we would have been limited to stop here. And you can show that by underlining. And then that means that the rest of these numbers are scientifically meaningless, even though mathematically they might have meaning. So that gives 1445, and that's correct. And mostly this is to make sure you learn how to use your calculator and raise to the third power. Then we've got 4.321 times 1 times 10 to the 5 over 1 times 10 to the 2. And these are in here to reinforce. If you did this by hand, you would say this is 10 to the 5 divided by 10 to the 2, so that's 10 to the 5 minus 2. You would predict an answer 10 to the third. The trick is to get your calculator to give the same answer, so we'll say 4.321, and then we're going to say times 1 exponent 5 divided by 1 exponent 2 equals. And that gives 4.321 times 10 to the third, which is 4,321. So what you want to learn to do on the different calculators, on this one, we're going to use this button here, which is EXP. So you would say, here we would say 1 EXP5, and that will give us the value divided by 1 EXP2, like that. On this one, it's a little bit harder to see. You have to say second function and then EE. So on this TI-30, that's the one that's allowed for the test. The TI-80 series is not allowed for exams. So that when you're doing your homework right there, you wouldn't be able to use. But this is, you will use EE and then put that in. So that one was correct. Next, we've got 5.123 times 10 to the 8 over 10 to the negative 2. And here again, if we did this in our head, we would say this is 10 to the 8 minus a minus 2. So we're expecting an answer 10 to the 10th. See if our calculator will do that. We'll say 1 exponent 8 divided by 1 exponent. And now we're going to use this button here to say that this is a negative number. Don't use this one because that means subtract. So we're going to say it's going to be a negative 2. So that's 10 to the 8th over 10 to the negative 2 comes out 10 to the 10th times 5.123. On the other calculator, to make a negative number, you would use this button here. So this one over here is for subtracting. This one down here is to change the sign. On this one, it's over here. This button is for changing the sign, and that button's for subtracting. Next one is 6.4 times 10 to the 6 over 10 to the 4th. And then that whole thing is squared. So here again, it's it's 1 times. So you need to know that 1 is there because when you're putting it in your calculator, you say 1 exponent 6 divided by 1 exponent 4 equals. That gives 100, and then you can square or raise to the power of 2. And that gives 10 to the 4th. If we were doing this in our head, we'd say 6 minus 10 to the 6 minus 4 is 10 to the 2, and then that's squared. So 2 times 2 when it's this relationship. So we would predict 10 to the 4th, and that's the correct answer. So you should be able to get it right with the calculator, and you should be able to check it with what you know to be true from whatever 10th or 11th grade when you had this. So that's that one. We got 3 to go. 27.4 times 32 over 9 times 10 to the 4th. So this is a little bit different now because instead of on a 1 here, we have a number.
This is on 1 thing.
Yeah, this is now, when you put this into your calculator, if you use your second function EE, then the calculator is going to know that the 9 and the 10 to the minus 4 are together and they're both on the bottom.
Okay.
So we'll say 32 divided by 9 exponent 4 equals, and that gives 3.55 times 10 to the minus 4, which is what you'd expect for that because this 4 is on the bottom. And then we times by the 27.4 equals. So that's 9.74 times 10 to the minus 3. What students will do is they'll say 32 divided by 9 times. And once you say that times, then the calculator thinks you had 32 over 9 times 10 to the 4th like that. And that will give you the wrong answer.
Right.
That'll kill the baby.
Yeah.
Okay, next we have 3.1 times 2.1 times 10 to the 2 over 1 quantity squared. So this is in here to make you realize that the 2.1 and the 10 to the 2 both have to be squared. So if you put this in exponential, if you say 2.1 EE2, or on the Casio you'd say 2.1 EXP2, then you hit the squared button of that. The calculator will know that this whole number goes together and will be squared.
Yes.
If you put it 2.1 and then you use times and then put the 10, then the squared is only going to be on the last thing you put in. So we've got 2.1 exponent 2 quantity squared times 3.1, and that gives us 136710, and 1, 2, 3, 4, 5, 1.367 times 10 to the 5. And here again, these are pure numbers, not measurements. So we don't have any basis for how much we can record.
So what did you just typed in 2.1 exponent EE.
Yeah, this is or.
2
right?
squared.
Yeah, this is on the TI. You would do this.
Yes.
And this is on the Casio.
And then did you just press times 3.1?
Did I forget to do that?
No, you were saying I just was. You don't need to.
Yeah,
put it in
yeah, yeah, yeah.
parentheses or anything.
Oh, no, right. The relationship of this to this quantity, right? You get this off the calculator, and then right here there's a
Okay,
times.
so you're gonna press equals after you type that in and get
Right.
that
Put,
number.
put
And then,
this,
okay.
hit the squared,
I
then
was
press
just
the
asking
equals.
the order you do it in.
Yeah, that's correct.
Okay.
And then this last one, we've got 3 times 10 to the negative 2 over 1 quantity cubed times 1 over 10 to the negative 6 quantity cubed. And you can do a couple things here. We could notice that 1 over 10 to the minus 6 would be 10 to the plus 6, and then that's cubed. So this would be 10 to the minus 2 to the third power. So negative 2 times 3, this would be 10 to the negative 6 after cubing. This is 10 to the 6 times 3, so this would be 10 to the plus 12. Right, so we got plus 12. What happened? No, this is 18. 6 times 3 is 18.
Mm-hmm.
So 10 to the 18th minus 6, there's my 12. I knew there was a 12. Would give 10 to the 12th.
Okay.
Right, so that's if you were going to do it just by eye. The other thing you could note, if these weren't such simple numbers as this, right, now here these are simplified because there's ones understood in both of those that you might have to supply. And the other thing is that these are both cubed, so you could say 10 to the minus 2 over 10 to the minus 6, because these are to the common power, you can merge them. And so sometimes it's more convenient to merge them first and then do the cube. So what I would do, if this was more complicated numbers that were a result of measurement, I would put in 10 to the no. You don't put 10. That's the whole point. You have to put in 1 exponent negative 2, because this is 1 times 10 to the minus 2, divided by 1 exponent negative 6 equals, and then x to the y that to the third power. That will give 1 times 10 to the 12th. 1 times 10 to the 12th, and then that's times 3.
Alright. So, okay. Alright. Yeah, I just did most of the, I mean, I did all of them by
Hold on a second.